Assalamualaikum and hi guys, Madam Jasmine here. So today we will learn about chapter 3, static and dynamic characteristic of instrument. Let's start. The first topic is static characteristic of instrument. So what is static characteristic? Is characteristic of an instrument which do not change with time. So there are 1, 2, 3, 4, 5, 6 example of static characteristic that you should know. Okay, first is error, second is accuracy and precision, next is sensitivity, reproducibility, drift and dead zone. Okay, first is error. No measurement can be made with perfect accuracy and precision. So there will be error in every measurement that have been made. So error is the actual difference between the true value and the indicated value. So we can simplify as error equals to indicated value minus actual value. Next, error can be classified by 3 types, which are systematic or cumulative error, second accidental or random error, and third is miscellaneous type of gross error. So what is systematic or cumulative error? It has the same magnitude and signs for a given set of condition, or we call it instrument bias. Okay, first, instrument error, poor design or instrumentation error, and then loading error by act of measurement on the physical system being tested, and other than that is environmental error. So it depends on the condition in the area surrounding the instrument. For example is humidity, temperature, pressure, forces and etc. So what about accidental or random error? It is due to random variation in the parameter or the system of measurement by lack of consistency in the measured value when the same input is imposed repeatedly in the instrument. Okay. For example is the presence of a certain system defect and change the tolerance. Okay, the third one is miscellaneous type of gross error. Okay, so it's either systematic or random error. So the example of this gross error is human error, okay, and faulty component, and also improper application of the instrument. Okay, next is accuracy and precision. So what is accuracy? Is how closely the reading of the instrument approaches the true value. Okay. Accuracy of a measuring instrument is expressed as a percentage of the true value of the measured quantity. So accuracy is equal to result minus actual value over actual value times 100. Okay, you will always use this, especially when you're doing your lab, your material lab, your strength lab. You will find this formula. So what about precision? Precision is defined as the ability of the instrument to reproduce a certain set of readings within a given accuracy. Okay, so let's read accuracy versus precision. So for this image is high precision with poor accuracy. Okay, next, good average accuracy with poor precision. And C, high accuracy, high precision and the poor accuracy with poor precision. Okay. Next, what is the differences between the accuracy and precision? So for accuracy is how closely the instrument measure the actual value. So your result minus the actual value divide by actual value and times 100. Okay, the actual value is your theoretical value. And for precision is the ability of measurement to produce the same output value on every time. Okay, as you can see, is the ability of the instrument to reproduce a certain sets of readings with a given accuracy. Next is sensitivity. Okay, what is sensitivity? Is how fast the output change with the respect to the input given. So sensitivity of a measuring instrument is expressed as the ratio of the output to the magnitude of the input signal, which can be expressed as static sensitivity, or we call K, equal to change of output signal divided by change in input signal. So output signal divided by input signal. Next is reproducibility. Okay, what is reproducibility? Is the degree of closeness with which a given value of a quantity is repeatedly measured within a closed range. In other words, is the difference between the largest and the smallest result. So what is the differences between reproducibility and repeatability? For reproduce is the closeness of output value when same input applied repetitively over short period of time with change of measurement condition, instrument observer, location, or etc. So what is repeatability? Is the closeness of output value when same input applied repetitively over short period of time with same measurement condition, instrument observer, location, and etc. Next, drift. Okay, what is drift? Drift is defined as the variation of output for a given input caused due to change in the sensitivity of instrument due to certain interfering input like temperature change, component instability, or etc. Okay, so drift in Malay means tergelincir. Okay, so the tergelincir daripada asal. So drift can be classified into zero drift or sensitivity drift. So next is dead zone. Dead zone is the largest change in input quantity for which a noticeable change in the output quantity is observed from zero reading or area of signal when no action occurs. Dead zone occur due to friction of the instrument, which does not allow the pointer to move from zero reading till sufficient driving force is developed to overcome the friction. Okay, so the keyword is the friction. Next, we move to the selection of instrument. In general, the selection procedure seeks to maximize the payoff ratio of the investment, which the ratio is the value of useful information divided by necessary total cost. So there are several value viewpoints that need to be considered. First, instruments quality, value guided, and second is the convenience aspect, value judged, and the third one is cost initial and cumulative total. So first is instrument quality. Accuracy and precision characteristic. sensitivity, linearity, zero. Okay. Its nature and type of data available. So what's analog ke, digital or continuous? Okay, and next is what is the nature and type of readout? So what is the indicator? Indicating or recording type? Okay. Digital or manual? Okay, next is further data computation, dynamic response characteristic, and susceptibility to environmental disturbances. This is the criteria of the instrument quality. Next is convenient aspect. What is the application of the instrument? Lab use, field use, or both? The suitability. And next, can the instrument adapt to different size of input, scale expansion, range change? Does the equipment is easy to calibrate? And then we should concern the material durability and non-fooling design. Okay. Foolproof assembly. Okay. We need to study what is the maintenance, repair, local representation, and steady delivery, and other criteria. Next is the cost, initial and cumulative total. So the important part is cost. What is the initial cost? Procurement cost, installation and accessory cost. And how about the maintenance cost? The repair, calibration, and running cost, and also expected lifetime. So we need to consider when we select an instrument. Okay, next is we move to dynamic characteristic of instrument. Just now we learned the static characteristic, and now we move to dynamic characteristic. So dynamic characteristics of a measuring system vary over time. The dynamic characteristic instrument can be determined by applying a known and predetermined input signal to its primary element and studying the output. So next we move to type of dynamic input signal. First, periodic signal with time period, varying cyclically with time or repeating itself over a constant interval. So as we can see here, okay, it varying cyclically with time and repeating itself after a constant interval. Next, transient signal, varying non-cyclically with time. Okay, sometimes the signal becomes zero after a certain period of time, like this. Okay, it non-cyclically. And then is random signal, varying randomly with time, with no definite period and amplitude. This may be continuous but not cyclic. As you can see here, it's random signal. Next is dynamic characteristic can be classified into steady state, periodic, and transient, which is transient is lasting only for a short time. Okay, transient, and this phase is transient. Okay, before it become steady state. By making simple assumption, most measuring system can be categorized as first order system or second order system. So these are the assumption that we made. Okay, the restoring element are linear, damping is viscous, which is consistent, and the system is a single degree of freedom system. Okay. Okay, there are two types of order system. So first is first order system. So this figure shows a mechanically model of first order system consisting of a spring and a dashboard in parallel along with a necessary connecting element AB which acted on by a force. These elements are the linear spring and viscous damper. There is zero mass in the first order system, so you should neglect the mass when you study the first order system. Next is second order system. So the difference of second order system with first order system is it consists of a mass. So you need to consider mass in second order system. Next video, we will learn the application of dynamic characteristic in instrumentation, and let's do the example in the next video. Okay guys, thank you so much. See you in the next video.